Hello, everybody, and welcome to
Hello.
another Microsoft Reactor live stream. Again, I'm joined here with Carlotta again. Say hello.
Hi everyone.
Yeah, it's great to be here. So thank you ever so much for joining again. It's apologies for the late start. I'm traveling. I'm in Israel at the moment, so I had to be a little bit later to accommodate and be able to run this stream and make sure we still get it done for you today. So again, thank you for joining. We are starting this session, or ending the series rather, with episode 3, deploying and consuming machine learning models. So let's jump into it, shall we? Let's get started. But before we do that, let's have a little talk about the code of conduct. So like every other stream that we do, I would like to remind everybody to please be respectful, please be kind, please ask great questions. Everybody's here to learn. We're all here for the same reason. So please just be yourselves and have fun. If you have any questions, we will pop them in the chat. Or if you pop them in the chat, we'll answer them as soon as we possibly can. And yeah, I hope you enjoyed this session. Right, what's on the agenda? So we are going to tell you a little bit about us, who we are, where we came from, and what we do and why. We're going to talk to you about the Cloud Skills Challenge that we have running, because I think we've only got about 15 days left of that one. We're going to deploy or look at deploying models with ML.NET and as Azure App Services. I can't get my words out today. And then we've got a bit of a demo where Carlotta is going to show you how you can consume a trained ML.NET model into a Raise app and deploy it to Azure, which is absolutely fantastic. So the practical session that we've all been waiting for is here upon us, and we're going to have some great fun doing it. So a little bit about me. Who am I? What do I do? So my name's Liam Hampton, and I'm a regional cloud advocate at Microsoft, based out of the Microsoft Reactor in London. And some of you may or may not have been there, but if you have, it's fantastic. If you haven't, and you can, come on down. We've got a couple throughout the world. And I'm also ambassador, which means I care about security through and through. I think about it first. I love it. It's something which I'm really passionate about. And I think developers, I'm here to make developers aware of what security is all about. I'm a Dev Network Advisory Board member, which means I sort of help run and organize conferences and hackathons, how they're judged, and just help create that standard across the board in the developer relations community. I write Go code, and I love to travel the world, which is one of the main reasons why I'm an advocate. Carlotta, over to you.
Yeah, sure. So for those of you who started watching the series today, let me just introduce myself. I'm Carlotta. I'm an academic cloud advocate. I'm based in Italy, and I'm focused on artificial intelligence and machine learning technologies, and I'm passionate about their use in education. So I support students and educators that want to use artificial intelligence technologies and Microsoft technologies in their daily job. And I love art in all its form. So music, cinema, painting, and I love visiting new places like Liam. And when I cannot travel, I just walk around the streets of my city, which is Rome, looking for nice hidden places. So let's get started.
Amazing. Yeah, Rome's a beautiful place, isn't it? I've been once before. I'd love to go again. It's absolutely fantastic. So you're in the best city. You're in a great city. And of course, tell us where you're joining from. Those of you who are watching, please do pop in the chat. Let us know where you're from. Let us know where you're joining in from. And yeah, we hope to be worldwide. We already said, look, Mike's already put in the chat for us. He's joining from California, USA. Thank you very much for joining. I appreciate it. It's probably quite early there as well. So, Cloud Skills Challenge. If you scan the QR code, you will get to a lovely web page, which will give you a bunch of information, a couple of links to click on, some of them being the YouTube channel, one of them being the meetup page from the UK Microsoft Reactor, which helps you also join our YouTube channel and whatnot. If you want to fill out the Cloud Skills Challenge and give it a go, I think it's definitely worth it if you're really interested in learning a little bit about ML.NET or just machine learning on a whole. Please do go to aka.ms/ML.NET series. And there you can just check this out and have fun doing it, right? This is all about learning, all about being building a community and enjoying ourselves. Oh, amazing. Joe from Israel. I'm also in Israel. Woo, it's amazing here. Cool. So yeah, give that one a go. Right, with every single session that we run, always try and do some learning goals. So the two learning goals we have today is to understand ML.NET models, deployment options at a high level. And the second one is to learn how to deploy a web app consuming a pre-trained ML.NET model as an Azure App Service. That is right, people. Azure App Service is not just for containers. It's all about consuming different types of technology. And ML.NET, machine learning models, is one of them. And I'm so excited to be learning this with you as well. And like every time, we always try and do everything that you can do for free. So if you want to give this a go yourself, you can sign up as a student. You can sign up to Azure for a free trial at aka.ms/A4S. And if you're a professional, basically anybody who's not a student, you can go to azure.microsoft.com/free, where you can get a Azure trial account to get about $200 of free credit, which you can use over, I think, 30 days. And you get access to a whole bunch of different services, which is absolutely fantastic. And of course, today we are going to have some prerequisites for you to be getting on with or needing in order to give this a go yourself if you're going to be following. So Visual Studio, numero 1. And you need this because everything to do with C# we're going to be writing in is going to be in Visual Studio. Now, of course, we mentioned in previous streams that you can't do this on a Mac, okay, because of the Model Builder plugin that you need. However, alas, you can still use virtual machines with Windows. You can still use lots of dev boxes, different ways to get around that one. You need .NET 6.0, and of course, that ties in with the Model Builder extension itself. Secondly, you need a GitHub account. So if you are a student, you go to aka.ms/student-devpack, where you can get a whole bunch of lovely things which are intertwined with students for, well, developers that are students for GitHub. Okay, absolutely fantastic. You get so many cool things with it. And if you're a professional, please just go to github.com and sign up, because you're going to need these. So what's the series about? We have already covered in episode 1, getting started with ML.NET. Episode number 2 was text classification with Model Builder. So Carlotta had an awesome demo where she showed us some tweets and seeing if they're sort of legitimate or not. And episode number 3, which is where we are today. And this is where we're going to deploy and consume an ML model, which I think is absolutely fantastic. And I can't wait for this demo because, like I said before, I am learning along with you. But there's one thing which I do know about, and it is DevOps. Now, we're going to kick this off with what ML Ops is. Okay, so deploying machine learning models, which are in, well, .NET ML models, right? So what is ML Ops? Okay, ML Ops is you've got like a whole smash of all different things. So if you think about DevOps, DevOps is a development lifecycle. Holistically, it goes around sort of from planning to coding to testing, building, deploying, monitoring, and you go around, okay? It's all part of the agile methodologies. MLOps is really not that dissimilar. It is a sort of a branch off of DevOps. So you've got machine learning, you've got the DevOps side of it, and you've got data engineering. So what makes a machine learning, or what makes a machine learning model, right? You need data for your input to get an output. You need something to train that model. And of course, you need a way to iterate over it. So what does the DevOps lifecycle look like with ML in it? So what does an MLOps lifecycle look like? There you go, getting tripped up already. Now, it looks a little something like this, where you have on the left-hand side, you've got your ML section. So you've got the model and the data. So the data you're going to be putting into that model. In the middle, you've got development. So you've got the planning, the creation, and then you've got the verify and the package as well underneath it. So it's all part of like it's a bit of an awkward one to explain, but if we go section by section, and then the final one, we've got the ops side of it. So you've got release, configuration, and monitor. So that is really not too dissimilar to the end of the DevOps lifecycle. Very, very similar. And it all kind of goes together, right? You can kind of see where one is coming into the next one and so forth. The only difference with this is we've just got machine learning models instead of just code, right? Do one extra step. So I think with this, I'm going to hand it over to Carlotta.
Yeah, thank you, Liam. Just wanted to add to this deck that the first 2 loops here in this deck, we covered them last time, and this time we are going to focus on the third loop, the third cycle of this process, which is actually deploying and consuming machine learning models. And talking about deploying machine learning models, of course, we have different possibilities of doing that in ML.NET framework and with Azure Cloud. I listed here free tools, free ways you can do that. For example, first of all, you can deploy and consume your pre-trained ML.NET model as an Azure function. So an Azure function provides an easy way to run small pieces of code at scale on a managed serverless environment in the cloud. And you can choose between an HTTP trigger if you want to invoke prediction as a REST API, or a time trigger if you want to periodically ask for predictions to launch your function that will consume your pre-trained model by loading it from a zip file or a remote URL. Like if you have your model in a GitHub repo folder, you can reference the GitHub repo. Another thing you can do is using the ONNX format, so the Open Neural Network Exchange format, which is a common file format to enable AI developers to use models, and which is agnostic to frameworks and runtime. And there's a library in ML.NET, which is called Microsoft.ml.onnx converter, that allow you to do this conversion. And then you can, for example, load your pre-trained model on an Azure machine learning workspace. And another option that is the one we have chosen for today's demo is you can integrate your pre-trained model into a .NET web app by instantiating a prediction engine and then deploy the app to the cloud using an app service. So in this case, we've chosen this modality for today because you can add a front end to your web app in a way that the user can consume the model and ask for predictions using a graphical user interface. As I say, this is the option we've chosen for today. And that's why, before going to our demo, I wish just to give you an overview of what's these resources we are going to use, which is called Azure App Service. So an Azure App Service is an HTTP-based service for hosting web applications, REST APIs, but also mobile backend on the cloud. It is fully managed platform as a service offering. And the key features are the ones listed here. You can develop your app with the language and the framework you prefer. Today, we are going to use C# as language and .NET and ML.NET for the machine learning part framework. You can leverage on DevOps optimization, because you can set up continuous integration and deployment by using GitHub or using Azure DevOps, for example. You have security and compliance features because you can provide user authentication with Azure AD, for example, or other types of accounts like Facebook or Microsoft accounts. And you also have integration with Visual Studio and Visual Studio Code, because you can create app service resources inside Visual Studio or inside Visual Studio Code and then deploy directly from those tools to Azure. Great. So let me introduce you a little bit the tech stack and the scenario we are going to use for the demo of today. So also for this episode, we prepared the demo to put into practice how what we have covered so far. So how to consume and deploy a machine learning model. And we are going to use the binary text classifier we trained in the last episode with Model Builder. So if you watched it, you know. Otherwise, it was a text classifier trained on a database of tweets published by Elon Musk throughout 2022. And it's a classifier able to identify if the input text is a fake tweet or not. Or if it's authentic. And we are going to integrate this pre-trained model in a Ask.NET Razor Pages application to enable app users to ask for prediction using a simple graphical user interface. So basically, a text area to take inputs. Now, ASP.NET extends the .NET Developer Platform with tools and libraries specifically designed to build web apps. And regarding Razor Pages paradigm, it is the preferred way to create page-based apps in ASP.NET based on a lightweight and smooth structure with respect to the classical MVC paradigm, model view controller, which often results in a lot of files and folders, which can be harder to handle and maintain. Now, I'll show you how to run this app locally on Visual Studio, but also how to deploy it on Azure to make it accessible to remote users using Azure App Service. And to do that, we're going to build a continuous integration deployment workflow using GitHub Actions, and that's why you will need GitHub to replicate this demo by linking a specific branch of our repo to our app service. And this let us, this linking let us, every time we do a pull request or an update on our GitHub repo on that specific branch, we automatically trigger a deployment on the Azure App Service. Now, let's not waste other time, and let's jump on Visual Studio and dig into some C# code. This is our Razor Page application. But before explaining you what this code is and what it's going to do, let me show you directly the output of the application, because it's easy to showcase directly what the application does. So by launching the application, I will get this web page here in the browser. As you said, as you can see, I'm running this locally, and that's why I have it on a local host. So this is my very easy graphical user interface of this web app. I have a text area in which I can type the tweet that I wish to verify. And then here I have the resulting area, let's say, in which this is a dynamic page. So as I type a tweet that I want to verify, the model receives the input and outputs the prediction if the tweet is fake or not. So outputs the predicted label that basically is a Boolean. Is fake yes, or is fake no, not. So it's fake or it's authentic. So on the left side we have the authentic label, and on the right side we have the fake label. So let me type, for example, a tweet that I'm sure is a fake tweet. So because this is something that Elon Musk should tweet. So he definitely will not ever tweet Carlotta is a friend of mine. And as you see, as I'm typing, the model is getting inputs from the web page, and I receive the predicted label as output, which is fake in this case. On the other hand, if I copy-paste here a real tweet from Elon Musk, which is the people of Twitter strongly agree that Twitter needs to be fixed. This is a real tweet from Elon Musk. And you can see that the predicted label in this case is not fake. So we are really directly interacting with the machine learning model and getting predictions about the input tweet in the web page, which is basically consuming the machine learning model in a web app. And we are doing that locally for now, but we will do that also in the cloud in a moment. But let me just going a little bit, revealing you what's under the hoods. The code is not, as the graphical interface is quite easy, also the code is not really complicated to understand. First of all, let's have a look to the structure of this app. So we have here we have the text classification, the text classifier configuration, so the machine learning configuration of the application. If you saw the other episodes, you know that this machine learning configuration has been built with the model builder, so using the Visual Studio machine learning user interface. So actually, this contains these classes, these files contain the code that the ML.NET model builder auto-generates to retrain and consume the model, as we have seen in the past episode. Again, the scenario, the text classification, and the dataset for this machine learning configuration are the same of last episode. So the dataset of tweets labeled as fake or not fake. And let me recall here that we didn't build a text classifier from scratch that would be time-consuming and would require huge amounts of data. What you've done is rather fine-tuned a pre-trained implementation of the NASBERT NLP model, so a transformer model which is available on ML.NET framework, fine-tuned on our specific scenario and on our specific dataset. Also, you can notice that we have a zip file here, the text classifier.zip, which embeds the pre-trained model in a zip format that can be loaded in different type of .NET application. In this case, we are going to load it in our Razor page application. Great, so this is the machine learning configuration. Then what we have the program.cs file. So this is the startup file of our app, in which we enable the Razor Pages services at the beginning. Basically, this code is automatically generated when you create an app with the Razor Page template, because these are the basic functions and the basic line of codes we need to run a Razor Page application. But what we added here to integrate the machine learning capability in the app was these lines of comments here. So we added a prediction engine to integrate the machine learning model in the app. And this prediction engine has basically three key characteristics. A model input, which is a model input class, which shapes the format of the object in input to the model. So basically the text we are passing through the web page. A model output class, which shapes the format of the object in output to the model. And finally, the file zip, the text classifier.zip file we have seen here, generated by the ML.NET model builder that we load in order to consume it. Cool. Now, next, what we have here in the structure of the app, we have the pages folder. As I mentioned before, Razor Web App are pages-focused web app, and there's in this folder is where the definition of each page is stored. In our simple application, we only have a single page, which is the home page, also called as index. But in general, each page in a Razor Web App, a Razor Page web app is a payload file, a CS HTML file that has the HTML markup with C# code using Razor syntax, and a CS HTML.cs file that has C# code that handles page events. Now, let's start by looking at the CS HTML.cs file. Sorry, it's hard to pronounce for me. Now, predictions will be made inside the main page of the application, so the home page. Therefore, a method that takes the user input and using the prediction engine pool we configured in the program, in the program.cs file to return a prediction needs to be added here. And in order to use the prediction engine pool configured in the program file, we have to inject it into the constructor of the model where we want to use it. Now, the constructor of the model of this page is the index model constructor, and injecting it, it means passing it as input parameter of this constructor. So as you can see here, we are passing a prediction engine pool. And then we are actually storing this prediction engine pool in into a class variable. And then the other key thing we have here in this file is the method handler of the events of the web page, which we called onGetAnalyzeTweet. So this is the handler using the prediction engine pool to make predictions from user input received from the web page. And then it finally returns the predicted label, so is fake or not, back to the web page in a way that it can display the results. So the marker can go to the left or to the right. Now, the results returned by this handler will be dynamically displayed on the index web page, as we saw in the demo. So let's now open the other file, which describes the web page, which is the index.cs HTML file. To make this page dynamic, sorry, first of all, let me just tell you that this file, we can see that it collects the title of the page, live tweet analysis, the text we display on the web page, so that the type the tweet you wish to verify, that was the text displayed in the text area, the emojis, all the HTML you have seen in the resulting web page is here, as well as the marker with the marker position, all the text and all the static assets are here in this HTML page. Now, to make this page dynamic and enable the web page to send inputs to the onGetAnalyzeTweet handler we have seen before, and vice versa, also enable the handler to send the output back to the web page in order to display the result, we need to add some code to the JavaScript file of this web page, which is called site.js, and it's contained in the www.root folder here, which contain all the static assets and style files like HTML files, JavaScript files, and CSS files. So let me open the site.js file. In this file, we can find we can find basically three functions. The first one is the get class function, which make a get HTTP request with the user input, so that the tweet we want to verify, to the onGetAnalyzeTweet handler. And below that, we have the update marker function to dynamically update the position of the marker on the web page as the label is predicted. And finally, we have the update class function, which is the event handler function that gets the input from the user, send it to the onGetAnalyzeTweet handler using the get class we have declared at the top of the file, and then update the marker with the update marker function. So it updates the marker position if it should go to the left or to the right. Great. So do we have any questions so far from the chat, Liam?
No, I think everybody's watching so intently. This is absolutely brilliant. Thank you, Carter. I mean, at the moment, Mike just says he really likes the icons from the web project. So I'd actually like to ask you where you got them from.
Actually, it's just the emoji you can find also on every social medias. But I love you. Yeah, I love that you noticed the emoji and the icons in the app. Great.
Yeah, it's good. So Mike took the words out of my mouth, but he just said he liked them, so I just wanted to ask where you got them from. Anyway, you carry on. There's no questions so far, but if you do have any questions, do put them in the chat. We will answer them as soon as we can.
Yeah, exactly. As I say, the code was quite easy and structured. So this is what I want to show you about the web app. Now let's go to the core of the demo, which is deploying this code on Azure. And as I say, there's more than one way to deploy this code on an Azure App Service. You can use Visual Studio directly. You can use the Azure CLI. What I'm going to use today is the Azure portal, since it's one of my favorite way of doing that. So if you go to the Azure portal at portal.azure.com, you can create a new resource of type app service by clicking on create. And then you're going, of course, to fill in a few property here, like the subscription, the resource group, the name that you want to, how do you want to name the new web app? For example, text classifier app. And then we are going to publish code, so we will not modify this. We are going to use the .NET 6 runtime stack. We are going to select the region which is the closest one to you. In my case, is Western Europe, so I'm going to choose Western Europe. You're going to choose also a Windows plan, which is the Azure App Service plan, on which you pay for what you use. So for how much do you use your Azure App Service, and then you can go ahead. Sorry, another thing I wanted to show you is in the deployment. Let's see if it loads. So anyway, this is all the properties you need to fill to create a new app service in the Azure portal using the UI. So I wanted just to show you another thing about the deployment, because as you can see here, you have an option about using the GitHub action settings to build a workflow for the continuous integration and deployments. So as I mentioned before, what happens here by enabling the GitHub action settings means that you can link to this Azure App Service a specific branch or a specific repo of your organization. So I'm going to choose here, I already have my GitHub account here. I can select an organization. I can select a repository, which is, in my case, let's see if I can, Getting Practical with ML.NET. And I can choose a specific branch, which in my case, I will choose the Razor Web App branch. So by filling these properties out here, I'm linking this branch of this GitHub repo to the Azure App Service in a way that every time I do a pull request or a merge into this branch, I trigger a GitHub action that will finally deploy a new version of the app on my Azure App Service. And when I create the app service, of course, I will trigger it by default because it's the first time I'm deploying something on my Azure App Service. And now I can leave all the other things as default, so I can go on the review plus create blade. I'm not going to create another Azure App Service now because it takes a few minutes, and then it takes a few minutes to trigger the GitHub actions. So I don't want to waste a lot of time. I just want to show you how it looks like. So when you click on the final create here, what happens is if you go on the GitHub repo, which you linked from the Azure App Service, in the Actions tab, you will see a new action here. and you will see, and it will run for a few minutes to build and deploy the app. And the final outcome, the final result of these actions will be the application itself. So you can navigate directly to your application on the cloud from the GitHub action. And you see that, of course, it's the same user interface we have seen locally. It's just deployed on the cloud. So instead of having the local host here, I have the address of the cloud, and this is accessible from anywhere, so from remote users. Great. So I have my Result Pages application not only on my local machine, but now I have it also on my on the Azure cloud, and I have a workflow to do a continuous deployment and continuous integration in the spirit of the MLOps we presented at the beginning. And yeah, I think it's all for my demo. I still don't see any specific questions in the chat. I don't know, Liam, if you have any questions.
No, I think you explained all of that absolutely superbly. I mean, it's amazing to see how we can now take, I guess, everyday development, or what we'd seem is now everyday development practices, and now turn them and sort of shift them on their head a little bit. Now, it's funny you mentioned this. So I'm at a conference currently, or I've been at a conference currently for the past 2 days called DevOps Days in Israel, so in Tel Aviv, right? And there was one of the booths there which was talking about different developments of DevOps. So if you think about it, you can sort of add operations onto a lot of different things now, right? Or have like a prefix. Maybe it's IoT, maybe it's AI ops, you've got ML ops, you've got so many different operations. This whole life cycle is kind of like an umbrella, I guess, for all these different kinds of methodologies. So I think it's absolutely fantastic that you went through that. It's brilliant to see ML ops in production. And sort of going through those kind of life cycles and kind of explaining it, because I think it's really important. Please do throw in the chat if you have any questions. I'm just kind of rambling on a little bit because I kind of want to just explain that with DevOps and the operations and the development side of it, you can add so many more different things into this, and it kind of fits in with the agile methodologies. It works really nicely. And I think it's brilliant that we can now do this with Azure, especially with such an available service. So if you have an Azure account and you do want to spin this up, like I said, it doesn't really cost anything at all with a free trial account. Absolutely brilliant. You can give this one a go. So what's left in the deck to go through? I think that was a brilliant demo. Thank you very much, Carter. It's been great going through this over the past couple of weeks, and thank you for people for joining in and coming back and watching the rest of these episodes. So again, we're just going to reiterate maybe the Cloud Skills Challenge. So please, if you want to scan that QR code or go to aka.ms/ml.net series, and that will again take you to the Cloud Skills Challenge. Please give it a go. Have a bit of fun, learn a little bit. Otherwise, if you want to replicate the demo that Carter has been going through the past couple of weeks, absolutely brilliant. Please do follow that link online. I will post that in the chat as well. I'll do that in just a moment. So in fact, let's get that in now, shall we? So people have a chance to copy that. So I'm just going to copy and paste that into the StreamYard, into the YouTube channel, wherever you're watching this from. There we go. So that's in. Give it a go. Have a bit of fun. Maybe you want to do something maybe with a different famous American figure. Who knows? See whatever they tweet, right?
Absolutely.
Brilliant.
Absolutely.
What else do we have? Yes, rewatch the series. So somebody actually beat me to this earlier, didn't they? I think it's Fred. Fred, you asked where we can see them. So again, if you go to aka.ms/watchml.net series, you can catch up on all the episodes that we've done. So all 3 of them are going to be live. They're video on demand on YouTube. So on the Microsoft React YouTube channel, you can grab. It's not just this series, absolutely fantastic, amazing series from all sorts of different cloud advocates across Microsoft, across the world. So even stuff or even episodes in different languages, which is absolutely brilliant. Yeah, give that a watch and have a bit of fun while doing it. Join in. And I think we can probably cap off with what's next. Now, what is next, everybody? Well, it's holiday time. This is, I believe, Carter, I think this is your final one as well, right? This is certainly my final stream or engagement of the year. So just want to say an absolutely well done to everybody. It's been a smashing year. Thank you very much for joining in throughout 2022 at the Microsoft Reactor. Enjoy a break, have fun, spend some time with family and friends, take care of yourself and loved ones, And yes, we will see you back in the new year. Please keep an eye on Meetup. Please keep an eye on the YouTube channel. But until then, I'd like to say thank you very much for everybody. And we will see you in the new year. And of course, if you want to connect with us on social media, here are our tags. If you want to follow on any of these, please do get in contact. Let us know what else you want to see. Maybe it can be something completely different, but let us know and we'll see what we can do. We have a question in the chat, Carter.
Yeah, from Mike. So are there more videos talking about the hyperparameters? So I guess you're talking about the hyperparameters tuning of machine learning models. So I'm sure that there are videos on Microsoft Reactor YouTube channel about fine-tuning hyperparameters and fine-tuning machine learning models. I'm not sure if you can find something about fine-tuning hyperparameters for in the ML.NET specifically, in the ML.NET framework specifically. But if you want to have a general understanding of how to fine-tuning hyperparameters for machine learning models, I'm sure you can find something in the Microsoft Reactor YouTube channels. There's tons of videos of machine learning and AI. Great.
Brilliant. I think that was the only question that we really had. But again, if you have any more and we're not online, you're watching this video on demand, grab our tags, ping us in the DMs, and we'll see what we can do. If I don't know the answer, then I'll certainly pass it on to Carlotta and vice versa. There's plenty of us here at Microsoft who can answer many, many questions about these kind of topics. So thank you very much for joining, everybody. It was a bit of a shorter one today, but certainly wanted to cap this off with a nice and, I guess, more of a free-flowing episode. So thank you very much, Carlotta. It's been
Absolutely.
a pleasure having you on. And
thank you.
Happy holidays and Happy New Year, everybody.
Happy holidays. Happy New Year. Bye.
Bye all.